All right, guys, so we're going to find the radius for this here. So we're going to look at this problem here first, and then we will start the lesson. So this one here, we're trying to find the radius of the circle. So the radius of the circle will be the line connecting Q to A will be our radius. Now, according to our theorems that we had with 8.3, the line intersecting this chord, if these two lines are congruent, then the chords are congruent as well, and they will also intersect at a right angle. So it'll make a right triangle. So the first thing we need to do is to find our lengths. Now the main lengths that we need to find are going to be one, this length here from the intersection to A, our other side of the triangle, so that we can find R. Now we do have one of the two lengths as 5. We just need to solve for x first. So the first thing we can do is set 4x plus 4 equal to 6x minus 6. Now we do need to get x, the x's together, so the first thing we can do is subtract 4x from both sides, telling us 4 is equal to 6x minus 6. The next thing we can do from there is to add 6 to both sides. No. Subtract 4, yes. 2x. I was about to say that wasn't going to work out nicely, because our 6x minus 4x should have been 2x, not 6x.
What are we doing? What did you check? No, not
6x minus 4x.
Okay.
So this is 10.3. We add 6 to both sides, telling us that 2x is equal to 10. And last but not least, we divide both sides by 2. So x is equal to 5. Now that's not the final answer. We needed to find x to be in order to be able to find the radius. Our next part is going to be plugging it back in. Now it doesn't matter which one we plug it back into, because they will give us the same value. So we can say 4 times 5 plus 4 would be 20 plus 4, which is 24. Now 24 tells me that the entire length from A to D is 24. But we don't want that. We want half of it. And it does work out that these two sections are congruent, which means this side is 12, because the whole thing is 24, so half of 24 is 12. Now they're not exactly drawn to scale as they should be, but based off the properties that we had in 10.3, yes, it's based off that, not so much based off the shape. So that's one of the two sides. We still need to find the radius. Now, let's get down. Because in the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So this theorem that we had from 10.3. Now it does work out that this here is going to be the midpoint, cutting those two in half. This is how we're actually able to find this here. Now, it tells us that this length is 12, this one's 5. We just need to find R. Now, since it is a right triangle, we can go back to a squared plus b squared is equal to c squared, Pythagorean theorem. One of the side lengths of the triangle is 5. The other is 12. And our third length is going to be the radius squared. We could have left it as c squared. We can call it r squared. Either one works. Now at this point here, we can do 5 squared plus 13, or not 13, 5 squared plus 12 squared in a calculator, and it'll give us 169. Now from here, we can take square root of both sides, telling us R is 13. Hopefully we got the right set of slides. So the radius is 13. We don't do the plus or minus because we know distances has to be positive, so we don't take the negative case into account. Any questions on this here? Okay. Okay. And then here's 130. So for this one here, we want to find the values of A and B. Now we know that the angles across from each other inside this quadrilateral do add up to be 180 degrees. Now, they told us that these two here, one of them's 54, the other is 130. So together, they're going to be 184 degrees. Angle K, which is the inscribed angle for this intercepted arc, is half of 184, which is, would be 92 if we divide it by 2. So that means that 4B and 92 should add together to be 180. So we have 4B plus 92 is equal to 180 degrees. Now, the only other section that angle that we're missing is this one here. But they did tell us that this is 110 and this is 130. So this whole section is. And angle J is going to be half that, so it is 120. So these here would add together to be 180. Is these two, 110 and 130, will add together to give us the whole arc, which is 240. And this angle J is the inscribed angle for it, so it's half the arc measure, which is 120. Let me get this set up here. We good with on how we set this up. Now we can solve for A and B. For B, the first thing we can do is subtract 92 from both sides. A would give us 100, so 88. Divide both sides by 4, so B is 22. For A, we would subtract 120 from both sides, showing us 3A is equal to 60. Divide both sides by 3, and A is 20. Any questions on any of this here? All right. We're going going to go on and start the lesson 10.5. Now, the first theorem we're looking at is this one here, tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of the angle formed is 1/2 the measure of its intercepted arc. So if we have a tangent line, intersects at one point, and we have an angle, then its angle measure is going to be equal to 1/2 the measure of the arc. So angle 2 here is 1/2 the measure of arc ACB. And angle 1 is equal to 1/2 the measure of arc AB. That's it. So if we look at this here, in our first example, for angle 1, the measure of angle 1 is equal to 1/2 the measure of arc AB. But we know that the measure of arc AB is what? Given to us as 130. So 1/2 of 130 is 65. So the measure of angle 1 is if we wanted the other angle, let's call it 2. How can we go about finding it? Because what do angle 1 and angle 2 make? Straight line. So we could take 180 and subtract 65 from it, and exactly, because 5, we would get 115. Now, the angle we're talking about is at 1 is not the angle where the circle and that line make. We're actually talking about the tangent line and that line itself. Does that make sense? Yes, we're talking specifically the red lines, not where that curve comes in. So this straight line here, and this straight line here. So this angle is 115 degrees. Now, if we go the other way from that, if we double it, we will get this arc measure. 0, carry the 1, 3, and this would be 230 degrees. 115 times 2, 5 times 2 is 0, carry the 1. 2 times 1 is 2, plus 1 is 3, 230. And 130 and 230 is indeed 360. So this all works out. Questions on this here? Well, it works the other way around too. So for this one here, we do have a tangent line, and we do have an angle, and we want to find the measure of this red arc. Well, the measure of arc LJK is equal to what? Twice the measure of angle L. And we'll have to call it L because, well, they did give us another point K, but they didn't give us a third point to actually name the angle. So twice the measure of that angle. Well, what is the measure of the angle? 125. So we're multiplying 125 by 2. Five times 2 is 0. Carry the 1. 2 times 2 is 4, plus 1 is 5. And 2 times 1 is 2. So the measure of arc LJK is 250 degrees. Questions on this here? We good with all this so far? We ready for the next one? So if this angle here is 240 degrees, what would we need to do to find the measure of our angle? Yes, we need to divide 240 by 2 or multiply it by 1/2. Either way. So we can take 240 divided by 2, which is, so the measure of angle 1 is 120. Questions on any of this so far? So if our angle is given to us as 155 degrees, to find the arc, it would be double it. So we're going to take 155 and multiply it by 155 multiplied by 2. What's 150 times 2? So, and then we add 5. 5 times 2 is? The measure of arc LJK is 310 degrees. Or we can do that in a calculator. Either way works. Questions on any of this here?
Lena Flores, please come to the office.
A little
Lena,
bit. It's
please come
using
to the
proximate,
office.
close numbers. Yeah, or what we did with 150. Yeah, because I took a number that I know I can double easily and then added the 5 to it. Essentially, I just did 2 times 150 and then added to it 2 times 5. So this is 300, that's 10. So it gives me 310. Do we feel comfortable with this here? Because if we were to find this here, it would be 105 because we divide it by 2. The measure of this arc would be 196 because we're multiplying it by 2. Uh, 9 times 2 is 18, so 180, and then 8 times 2 is 16, so 180 and 16. Or 100 times 2 is 200, then we subtract 2 times 2, 4 from it. Different ways to get there. Sometimes it's, I've done it so long the numbers just pop in my head. Whenever they do that, I always second guess it. But I think we feel comfortable with this, yes? Because this here is intersecting lines and circles. Intersecting lines and circles. Now, for the most part, especially with inscribed angles, we're either multiplying it by 2 or dividing it by 2, multiplying it by 1/2. Now, intersecting lines and circles. If 2 non-parallel lines intersect a circle, there are 3 places where the lines can intersect. Makes sense, because if they're not parallel, they're going to intersect at a point. Now, they're either going to intersect on the circle, inside the circle, or outside. Only 3 places where they can intersect. On the circle, inside the circle, or outside the circle. Now, so far, out of these 3, we've already covered this one, on the circle. Because if it's on the circle, it's an inscribed angle. And we've gone over how to do this. Now, the 2 that we're going to look at now are inside the circle and outside the circle. Angles inside the circle. If 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle in its vertical angle. So here, angle 1 is equal to half the sum of these two here. Angle 1 is equal to half the sum of those two angles, those two arcs. Angle 2, different color, is equal to half the sum of these two. Now, it's also true for 1 and the angle across from it. It'll be true for either one of those because those two angles are vertical angles and vertical angles are congruent. Same thing is true for 2 and the angle across from it. Now, outside the circle, if the two lines intersect outside the circle, and it could be any one of these here. If a tangent line and a secant, two tangent or two secant intersect outside the circle, then the measure of the angles formed is 1/2 the difference of the measures of the intercepted arcs. So our angle is equal to bigger minus smaller. Bigger minus smaller. And the bigger is always going to be the arc that is farthest away from the angle. Because as two lines go away from each other, they're going to get wider apart, so the arc should be bigger. Now, it doesn't matter which setup that we have of these three here, it will give us the same result. So let's look at some examples of this here, because seeing it as a theorem is one thing, but working this makes it make a little more sense. So as we look at this here, x, angle x, this angle in the center is equal to half the sum of the two arcs. So x, according to the theorem, is equal to half the sum of the two arcs here and here. We have half of 130 plus 156. X is equal to half the sum of these two arcs. Questions on how we set this up? Well, at this point here, everything on the left or on the right-hand side is all a number. We could plug 1/2 parentheses 130 plus 156 into the calculator, hit enter, and it would tell us the answer. If we work this out by hand, we can add these two together. 130 plus 156, 286. So x is 143. And that is it. Questions on this here? You ready for the next one? Now this one here is x inside or outside. Outside, the two lines intersected outside. So what it's telling us is that this angle here is still equal to half the measure of the two arcs, but the two arcs are being subtracted. Now which one's going to go first, 76 or 178? And we would subtract them, yes? Well, is this going to give us a positive number? No. Yeah, it just worked out. They both had a 7. The bigger arc is always going to go first. Bigger arc's always going to go first. 70. Yes. Thank you. That was erase the 6 and wrote a 6. Yeah, so 178 and 76. Tried to be slick and it didn't work out. So the bigger arc always goes first with this one here. Bigger arc always goes first. Now with the other one, it really doesn't matter. Addition, adding two things doesn't matter. But with this one here, because we're subtracting, the arc farthest away from that angle is going to go first. It's going to be the bigger of the two. So we'll say 178 minus 76. Well, 178 minus 76 is 102. Now we have to take half of 102, which is 51 degrees. So the measure of that angle is 51 degrees. Questions on this here? Any questions on any of this so far? Now looking at this one here, we do know that this here, I'm going to call it A for now. We'll actually give it a number here in a minute. But this angle, or this one here, because we know those are both the same, either one of these is going to equal half of the sum of these two arcs here. One of them's 80 and the other is X. Yes? Now, unfortunately, I can't leave those as A, because if I do, in this equation, we would have two variables. And even in Algebra 2, we cannot solve for two variables at the same time. But do we get how we set this up, or why we set this up this way? Because the only way to get at X is using this formula here. The interior angle is equal to the sum of the two arcs. What do we know about a straight line? Does 94 and this A make a straight line? So to find out what that measure is, we can subtract 94 from well, this one also is 86. So we're saying that 86 is equal to 1/2 of 80 plus X. Any questions? We can distribute, yes. So we can distribute the 1/2, which is going to tell us that 86 is equal to, well, 1/2 times 80, or half of 80 is 40, plus 1/2 X. Then we can subtract 40 from both sides, which tells us that 1/2 of X is equal to. Now at this point we can divide by 1/2, or we could multiply by 2. And this should give us .46 divided by 1/2. Because when we divide by a fraction, we change it from division to multiplication and flip the second. Because 46 divided by 1/2 is the same as 46 times 2, which is, yes. So we are definitely going to finish this up tomorrow, guys. Yeah, it's 3 o'clock. So, London, hold on for a second. Edith, if y'all will hold for just 1 second. I want to do this one here. So, guys, let's look back at this one more time. I'm going to, now, one thing I want to, so we started here. We were good with setting this up, yes? Is 80 and x both divisible by 2? 80, yes. X, no. We end up with 1/2. Now, what we did does work. What I can do also, because of this 1/2, if I multiply it by 2, 2 times 1/2 is what? 1. Because we can say 2 times 1/2 is 1, yes? So if I multiply this side by 2, that simplifies, leaving us with, but what I do to one side, I have to do to the, so I'm going to do 2 times 86. 2 times 6 is going to be 2. Carry the 1. 172. We're good with this here. Now we could have divided by 1/2. So we could say 86 over 1/2 is 172. We get the same thing. So what do we need to do to get x by itself? So it works out to be the exact same thing. So there are 2 different ways to do it. One of them has a few less steps. Now, distributing the 1/2, I would say, is very nice, especially if instead of x we had, say, 2x. Then it would be a little bit easier. Questions on any of this here? So y'all can go on and go. We're going to do one more of these, and then we'll pick up this tomorrow. Any questions on this here?
But now we're doing it and it says that answer, but it's bad. Oh, because I multiplied in it.
Okay. Hang on to it.
Okay.
That way we can look at it.
I put a question mark by it because I wasn't sure if it was right or not.
See here. Almost there. 1/16. Yeah. Oh, 28. Wait. 16?
Yeah. Oh, I got 16. X is
So if you want to take a second, you can look at that there, or we can ask. Yeah, I can answer it tomorrow. Okay, guys, this one here is the last one we're going to look at today. We will finish this up tomorrow. Now, this one here, we're finding the value of x. Now, they told us the exterior angle is 35 degrees. Well, the exterior angle is equal to 1/2 of the bigger arc minus the smaller arc. And we know 100 is bigger. So how do we know 100 is bigger than x? It's farther away. It's going to be farther away, so it will be the bigger one. Yes. Now, we can multiply both of the numbers inside the parentheses by 1/2, or we can multiply both sides by 2. 35 times 2 is indeed 70. So let's focus back in. So we can minus 100 from both sides. Negative 30 is equal to what? Negative x.
Have to add 30 from both sides, so
We could do that, or we can multiply both sides by negative 1. We can divide both sides by negative 1. But we can also, I think at this point, guys, at this point, if we know that negative 30 is equal to negative x, x should equal 30. Because a negative, negative, positive. So this is where we'll stop for today. We'll pick this up to